How to classify fractions. Basic fraction classification identifies individual fractions by their type according to certain characteristics. Beyond the basics, you can also classify fractions based on how they relate to other fractions within a group or set. Steps. 1. Define the term fraction. A fraction is a specific type of numerical expression in which one quantity is divided by a second quantity. Another way to think of a fraction is as a value that represents a portion of a whole. For example, if there are 8 apples and you take 3 of them, you have taken 3 of the 8, or 3/8. Written in fraction form, the value would be presented as 3/8. 2. Distinguish the numerator from the denominator. Simply put, the numerator is the number on the top and the denominator is the number on the bottom. When treated as a mathematical function rather than an expression, the numerator is divided by the denominator. For example, with the fraction 5/9. The number 5 is the numerator. The number 9 is the denominator. Part 1. Classify individual fractions. 1. Point out a proper fraction. In any proper fraction, the numerator is less than the denominator. Example, 2/5. Every proper fraction expresses a value that is less than 1. A proper fraction represents a partial portion of a whole. For example, if there are 5 books and you read 2 of them, you have read 2 out of 5 books, or 2/5. Written numerically as a proper fraction, that would be 2/5. 2. Pick out an improper fraction. For any improper fraction, the numerator is larger than the denominator. Example, 5/4. Every improper fraction expresses a value that is greater than 1. An improper fraction represents an amount that is greater than a whole. For example, if you were only supposed to sleep for 8 hours but ended up sleeping for 9 hours, you have slept for 9 out of 8 hours, or 9/8 hours. Written numerically as an improper fraction, that would be 9/8. Also note that an improper fraction can be expressed as a mixed number. 3. Know what a whole fraction is. With a whole fraction, the numerator and the denominator are equal. Example, 3/3. Every improper fraction expresses a value equal to 1. A whole fraction represents an amount that is exactly equal to a single whole. For example, if there are 3 pieces of candy and you eat all 3 pieces, you have eaten 3 out of 3 or 3/3 of the candy. Written numerically as a whole fraction, that would be 3/3. In the same example, you could also write that you have eaten the whole amount, or 1 serving. Note that a whole fraction differs from a whole number. A whole number refers to all positive counting numbers, 1, 2, 3, 4, 5, and so on. Whole numbers also include 0 but do not include negative numbers. 4. Identify a mixed number. A mixed number contains both a whole number, or integer, and a fraction. Example, 1, 1, 2. Writing a value as a mixed number allows you to avoid the use of improper fractions. Like an improper fraction, a mixed number represents an amount that is greater than a whole. Unlike an improper fraction, however, a mixed number expresses the whole separately and identifies the remaining partial whole, as well. For example, if you are supposed to sleep for 8 hours and sleep for 9 hours, instead, you have slept for 9 out of 8 hours. You could also express this by stating that you have slept a full whole, 1, as well as 1 hour of an additional 8-hour cycle, or 1 out of 8, 1/8. Written numerically as a mixed number, the value would be 1/8. Part 2. Classify fraction groups. 1. Classify homogeneous fractions. In a pair or set of fractions, if the fractions all have the same denominator, they are said to be homogeneous. Example, 1, 7, 4, 7, 9, 7. These fractions represents values of a whole that are divided into the same portions. For example, if the serving size of one type of candy is 7 pieces and the serving size of a second type is also 7 pieces, both fractions would be represented in a homogeneous pair of sevenths. Homogeneous fractions can be added and subtracted as they are written. 2. Identify heterogeneous fractions. Fractions within a pair or set that do not have the same denominator are classified as heterogeneous. Example, 1, 3, 2, 5, 7, 6. These fractions represent values of a whole when those wholes are divided into different portions. For example, if the serving size of one type of candy is 3 pieces and the serving size of a second type of candy is 5 pieces, those serving sizes will be represented as thirds and fifths, respectively. Note that heterogeneous fractions cannot be added or subtracted as they are written. They must first be changed into homogeneous fractions. 3. Pick out equivalents. Equivalent fractions within a pair or set are those that have the same value when reduced to their simplest forms. Example: 1, 2, 2, 4, 3, 6, 4, 8. If you simplified or reduced each number in the above example set, all 4 numbers would equal 1, 2. 2 is half of 4, 2, 4, 3 is half of 6, 3, 6, and 4 is half of 8, 4, 8, just as 1 is half of 2, 1, 2. You can check for equivalent pairs by cross-multiplying the fractions, as well. When you cross-multiply fractions, you multiply the numerator of the first fraction with the denominator of the second, and the numerator of the second fraction with the denominator of the first. If the two products are equal, then the fractions in the pair are equivalent. Example: 3, 6 and 4, 8. 3 times 8 is equal to 4 asterisk 6. 24 is equal to 24. Part 3 Additional classification. 1. Identify irreducible fractions. Fractions should always be reduced or simplified to their smallest equivalent form. When a fraction is simplified as much as possible, it is then classified as irreducible. Example: 4, 7, 1, 3. To determine if a fraction can be reduced further, divide both the numerator and denominator by the value of the numerator or by the greatest common factor between the numerator and denominator. For the fraction 3, 9, divide both the numerator and denominator by the number 3. 3, 3, 9, 3, equals 1, 3. The irreducible form of the fraction is 1, 3. For the fraction 6, 15, divide both the numerator and denominator by 3. 6, 3, 15, 3, equals 2, 5. The irreducible form of the fraction is 2, 5. 2. Note that fractions can be either positive or negative. As with integers, fractions can either be positive or negative. A negative fraction is represented by a negative sign, comma, placed directly to the left of the number. Example: 5, 9. Other than the negative value, these fractions can be classified using the same sets of rules you would use when classifying individual fractions and fraction sets. Part 4 Sample problems. 1. Classify each fraction individually. From the following set, identify the proper fraction, improper fraction, whole fraction, and mixed number: 9, 5, 3, 1, 4, 7, 9, 3, 3. The proper fraction is 7, 9. The improper fraction is 9, 5. The whole fraction is 3, 3. The mixed number is 3, 1, 4. 2. Classify each fraction pair. From the following set, identify which pair is homogeneous, which is heterogeneous, and which is equivalent: 3, 9, 1, 3, 2, 3, 4, 3, 1, 6, 2, 5. The homogeneous pair is 2, 3 and 4, 3. The heterogeneous pair is 1, 6 and 2, 5. The equivalent pair is 3, 9 and 1, 3. 3. Identify the irreducible fraction. From the following set, identify which fraction is irreducible and which fractions are reducible: 6, 12, 3, 9, 4, 7, 4, 2. The fraction 6, 12 is not irreducible, it can be simplified to 1, 2. The fraction 3, 9 is not irreducible, it can be simplified to 1, 3. The fraction 4, 2 is not irreducible, it can be simplified to 2, 1 or 2. The fraction 4, 7 is irreducible. It cannot be simplified any further than it already is. 4. Identify the negative fraction. From the following set, identify which fraction is the negative fraction and which is the positive fraction: 1, 2, 5, 7. The number 1, 2 is positive. The number 5, 7 is negative.